Hello friends, I welcome you in lecture number 7 on applications of integration. In this lecture also we will discuss one more problem on disk method, and this problem was asked in GTU Winter 2019 exam. First we understand this question. Find the volume of the solid generated by rotating the plane region bounded by y equal to 1 by x, x equal to 1 and x equal to 3 about the x-axis. And we can see these two are lines parallel to x-axis, and y equal to 1 by x is rectangular hyperbola x into y equal to 1. And we are familiar with the shape of this rectangular hyperbola. Its shape is like this. It will go parallel to x-axis and in this direction parallel to y-axis. So it is having two branches. Both branches are mirror images of each other in first and third quadrant. So this is the famous curve rectangular hyperbola. So we have to first sketch the region bounded by y equal to 1 by x, x equal to 1 and x equal to 3. So here I have considered this graph of y equal to 1 by x, and this much distance I have taken as 1, so this is 3, and we consider these two lines x equal to 1 and x equal to 1 by 3. X equal to 1 is the line parallel to y-axis passing through this point. So this is the line x equal to 1, and x equal to 3 is the line passing through this point and parallel to y-axis. So these are the lines parallel to x-axis. This is x equal to 1, this is x equal to 3, and this is the graph of y equal to 1 by x. This is x equal to 1, this is x equal to 3, and we have to rotate this plane region about x-axis. So this is the plane region bounded by y equal to 1 by x. This is x equal to 1, this is x equal to 3. So now we imagine what will be the solid generated by rotating this plane region about x-axis. So first we have to copy this. This is, suppose we are considering three-dimensional solid here. So we can see this is the plane region which we have sketched. It is like this. So now to imagine the solid which will be generated by rotating this plane region, first we consider this much distance below x-axis, and we copy this graph. We take reflection of this graph or mirror image of this graph with respect to x-axis. So it may look like this, and then we join this. The solid of revolution will look like this. So this is the solid of revolution which we can obtain by rotating this plane region about x-axis. Now as usual, to find out the volume of this solid, we have to consider cross section perpendicular to x-axis. So if we take the cross section of this solid perpendicular to x-axis, then cross section will be a disk of radius y, and the thickness of this disk will be delta x or dx, and radius of this disk is this distance from this curve to x-axis, because the center of this disk will be on x-axis. So distance from this point to this point is the radius of this disk. So this much distance is the radius, and that distance is y, which is given by 1 by x, and the thickness is delta x or dx. So now it is clear that if we consider the cross section of this solid, we will obtain circular disc of this type, and radius of this circular disc is y, which is given by 1 by x. We can write this as a function of x also, and we are rotating this region from x equal to 1 to x equal to 3. So the limits of integration will be from x equal to 1 to x equal to 3. So now things are easy. We are interested in the volume of solid of revolution, volume of solid of revolution is v equal to integral from 1 to 3 pi into y square dx. So this is going to be pi into value of y is 1 by x whole square dx. So this is equal to pi is outside integral, it is constant, and this is going to be 1 by x square, that we can rewrite as x raised to minus 2. So integral of x raised to minus 2 is x raised to minus 1 divided by minus 1. Limits of integration are from x equal to 1 to 3, and this we can rewrite as x raised to minus 1 can be rewritten as 1 by x. X is from 1 to 3. So first we put x equal to 3 minus 1 by 3 minus minus plus x equal to 1, that is 1, and 1 minus 1 by 3 is 2 by 3. So the value of volume is v equal to 2 pi by 3. Okay, so in this way we can easily find out volume of the solid generated by rotating the plane region about x-axis. So we will keep in mind that when we are rotating about x-axis, we will consider the cross section perpendicular to x-axis, and this cross section is a circular disc of radius y, and this y is given by 1 by x, because we are considering different discs of different radius. So radius of disc is variable, it will depend on x. At this point we will have another radius, but it is going to be function of x given by 1 by x. So for this also radius is y, which is equal to 1 by x. So by considering this type of discs, we can obtain the volume of the solid generated by taking integral of all possible areas. This pi y square is the area of the circular disc. So we are considering all these areas of this disc, and as we are taking number of discs tending to infinity, the volume will be given by integral. So this was about this session. I hope you like it. Thank you very much.